Hello everyone and welcome to the online meetup with GDG Cloud and Cloud Native Bangalore meetup groups. My name is Ransi and I'm the organizer for the GDG Cloud Bangalore. And today we are discussing part 2 of the Kubernetes operator using Go with Abhijit Chatterjee, who is the founder of Kubernetes Pedia. Okay. So without further ado, over to you, Abhijit. Take it away.
Thanks, Ransi, for a nice introduction. Namaste, everyone. And I'm also the founder of Kubernetes Pedia. So this is the part 2 of our Kubernetes operator session. So in the part 1, we already discussed what are the Kubernetes component and how we can utilize Kubernetes API to build the Kubernetes operator. And in this session, I will also talk of the framework that is available and which helps you to build the operator in a very quick way. And then I will also show you that how to start building a Kubernetes operator. And if it is possible, I'll try to complete the whole session today as well. So let's recap some of the things that we have covered in the previous session. So this is, you can see, this is the Kubernetes component. So in a cluster, there are control plane and the node. In the control plane, we have API server, we have scheduler, we have EDC for storage, and in the node, we have kubelet, proxy, and also we have Cloud API if you're using cloud. And here I just introduced a little more about what are the control plane components. And here you can see that Kubernetes is exposing the Kubernetes API in a REST. So Kubernetes API is something we need further to build our Kubernetes operator. And here you can see what are the node components we have. So we have kube proxy, kubelet, container runtime, and this is where we are having some set of pods also, like the content Docker container that you are running inside of this node. Now a guide like how you can install it. But for doing this, since this tutorial is basically based on the Go, you should have the Go client installed. So first is the Kubernetes Kube Builder. So Kube Builder I prefer because this is very easy to build a framework. And you can also use the Operator SDK and Go client. And these three are like, all of them are more flexible. Like you can use any one of them and it should solve your purpose. Let's go into the Kube Builder. So if you just open this site, this is the Kube Builder homepage. It will tell you like how you can deploy. First, you need to install the Kube Builder. So you can see that what are the things you need to have before running it. You need to have the Go, you need to have the Docker, and definitely you need to have the kubectl where you are going to deploy it. And for the installation, you can go through this installation doc. And from here, you can download the latest version. If you don't want to use the latest version, you can just install anything else as well, any other preferred version. And then you can just run Kube Builder to check the version. And before doing everything, you should have the Docker installed. Go installed. Docker also you need to build the image, like the operator that you will have in your local. You need to build it and you need to push it to the Docker hub, right? You can have your private repo or you can have the public Docker repo as well. Next, this is the Kube Builder. Next, say Operator SDK. So this is the Operator SDK. They have their official guide also. You can see here Operator SDK website. Here you can find, so this is what we are using, develop with Go. So here you can find how to install Operator SDK and how quickly you can start using it with your own project. And similarly, you can find Go client as well. They have a good documentation in the GitHub itself. So what we are trying to do in this process, so this is a very simple application that we are going to build. So basically, you know about deployment or stateful set. Those are kind of they are kind, right? So here also we are building our own kind. And it will be like we have some set of the desired set of pods that should be running. And so we have the custom controller also. That controller will check if it is not if it is less than the desired state, then it will just make it ready, and this loop will keep continuing. So let's say we are going to build one application, and we can give this application a name kind is uh, like app, mobile app, whatever app API. Let's say the app API. So it will see that what is the desired state of the app API. If you are saying that it has to be 2, but in case if it is not 2, if it is less than 2, let's say 1, or if it is not running somehow, then it will that so it will have a reconciler process which will check the desired state, and it will just make that state for that operator. And if it is running fine, then it will not do anything. So to do this, you can see that I installed a VM. uh, I spinned up a VM in the GCP, and I'll show you my Go version. Sorry. Here. I installed it. Let me install once again. So I'm using Ubuntu. You can follow this. So here you can see the latest Go version is 1.17, but in this case I will be using 1.15. That is because I know the Cube Builder version that I have, it will support 1.15 only. I will show you what version I have. Yeah, so this version it will support Go 1.15. So let me install Go 1.15 only. Uh, Instead of 1.17, I will make it 1.15. This is not for Mac, sorry. I need to do it for Linux. Yeah. Okay, so I installed Go. So right now I have Go 1.15 version. So let me go back. fine. So let me start building it. So first let me create a directory, empty directory, and name it app API. Now if you want to see what are the command it has, Cube Builder, you can just do Cube Builder and help. It will give you all the commands that you can have, like you can use alpha, create, edit, help, init. Init is necessary when you are going to start a empty project, because we don't have any component here and we are going to have an empty project. That's why we will be using the init. Okay, so we are using init, so we need to have a domain name. That looks fine. It will take some time. It is basically downloading all the packages. Should take 2-3 minutes more.
Can you increase the font size, Abhijit?
Yeah, sure. Is it better now?
Yes. Thank you.
Okay, so we see that it has initialized the directory. Like you can see that we have some files here. It was not there previously. So right now we are ready to work in the Cube Builder and build our operator that we did using the Cube Builder init command. Next, we have to build the API. So if you do this, yeah, so here you can see that it is saying that define a resource with API. So we'll be creating the API by using the Cube Builder create API command. Group name you can give, what should I give? Can give batch. Version will be using v1. And this kind, yeah, so this kind is important here. So you should give this name. That name you will be using in your deployment file. So in case of if you do any deployment or if you build any service in there, you use the kind service or kind deployment, right? So here you will be using kind app API. So you can do it. Yes, we need resource and you also need the controller. So it will create a default resource and controller, and that Go file you can modify before make your project. Oh, sorry. So it is giving me error because this kind name should start with an uppercase. Right now we can see that it is downloading the resources. And you should look in the structure. So here you can see that we have the primary file, which is main.go, and in the config directory we have the config, and this is the docker file. So at the end we have to build the docker image, right, for the deployment. So this is the docker file, and this is the make file. So when we'll be complying in the go, so I can show you this main.go. Here you can see, so this data is already populated by the Kube builder only. You don't need to do much modification here. Here you can see that, yeah, so these are the default data which is like popped up using Kube builder. Next, I'll show you what we have in the config. In the config, you can see that we have manager, we have CRD, we have Prometheus also it is having, or it is also having the RBAC. So RBAC is necessary because in our application, we want to scale it based on the horizontal auto scaling, right? Based on the CPU and memory uses, we want to have some more number of pods in our operator. So that is why we need the RBAC. I'll show you like what are the modifications we need to do here. And let's first open the CRD. Okay, we have API. Let's see what we have in the API. So okay, so here you can see that we are using API v1. So inside that API v1, we have app API types. What are the types that we can have? Then we can have the group version. Then we have the generated dip copy. So you don't need to worry about this. What we first need to check is that we need to have some modification here, which is app API underscore types dot go. Okay, so here also this file is automatically generated, and here you can see that we have type app API spec. Uh, so if you can compare it with any existing kind that you have in the Kubernetes, it could be either deployment or uh, stateful set. You can have some, like you are having some limit, right? CPU limit, memory limit, and what are the things we need? Like we need to have the image also, we need to have the port also. So we can add those type here. This we don't need, we can comment out. You can first start with the image. Image will be string. So we have one image, and what we need port as well. That port will not be string, it will be number, so we can have int. Now what we need? We need a replica. Yeah, that is important. Minimum and max replica, right? In replica. And similarly, we need to have the max replica as well. And we need the CPU request, right? And we can have the CPU request. Yeah, limit also we will have. First, let's do request, and that is also int, right? Next, we need CPU limit. Sorry, it has to be request. Then what are the things we need? We need CPU request. We need memory as well, right? We can have mean and max memory. Memory request. Okay, we are done. So we have image, port, min replica, max replica, CPU request, limit, and similarly we have memory request and memory limit. Next is the type app API status. So here basically it will see what is the status, like if you just do describe of a pod or describe of a deployment, it shows some status, right? This is the number of replicas running, this is the desired number of replicas. So it will handle like what will be the status, the final status of the application. So we need to have a status field here as well, and we can call it current replicas. Okay. I think this is good. It's good. Now I'll show you like how it will look. Samples. Okay, so you see this is how it will look like. So here you can using the API version batch my domain vi, and then kind is app API, then name. So in your regular deployment you can use some other kind like service deployment, but in our case we are using the kind app API. Now this is the field. So why we are adding those field there? Because uh, we can keep adding the fields here, but the controller that we will be writing, right, it should identify what is the value of that field. Like it should identify those field. Like we right now we can have image here, we can give the address of the image, or we can uh, have CPU request, or similarly a memory limit, right? So it will come under resource. Yeah, so right now we can have all those filled here, uh, but before that, if we don't add them into the in our API, but if we are trying to use any kind, we will not be able to use it, right? Because it will simply not work, because those fields should have present in that API that we will be writing. So let's say probably if you want to run some memcache or any other, or probably your application, right? Any Docker application, any Python based or any Java based application, and you want to use that API. So there you can just use the app API, which is the kind app API. And in the image field, you can have your image there. Like you will be hosting your Docker image somewhere, right? You can have your image there. Now, how this operator will be working is that it will see what is the status of your replica set, because you can have a name something called uh, sorry, that's fine. So instead of that, let me see app API sample Abhijit GDG, right? So I want to create a kind app API, and I want to name it app API sample Abhijit GDG. Now I am running a Flask server, right? And that Flask server, uh, let's say my Docker username is Abhijit, and then my Flask latest, right? I can write it like that, because whenever I am using this API version and this kind app API, so this operator will be applying to the image that I am deploying, and my operator will be checking the desired state. So you can have a desired state here, and this operator will be checking if it is not matching the desired state, or let's say if it is not to 1 or it is less than the desired state, or in some reason that container is not running, so it will try to spin up the container, it will try to modify the replica set count to make it running. And similarly here you can have some CPU memory request as well, so that container will be taking those amount of memory or CPU. Or similarly we can have the HP enable as well, like if you want to horizontally scale it. So this is basically the same thing that you do in the deployment. We are trying to just make it another, or should I say another kind, which is like same what deployment does, just for our this sample purpose. So this is a sample file. I'm just exiting from here. Okay, now we have API v1. Let me say one more thing. API v1. And you can also see the group version info, right? That group version info, you don't need to modify anything, but you can just check it here. You can have this the group name, which is the batch, because I use the batch name in the kube builder command while building it, and the version we use the v1 version, and that data is also, this variable is also automatically populated here by using the kube builder only. Okay. Now the main thing is the controller. So this custom controller will be doing this job. So if you just look in this PPT, we are having the where it is checking the desired state, and then it is finding if it is less than the desired state, then it will not do, like if it is less than, then it will run the custom controller. So in the custom controller we should have some logic which will help us like to get the current count, and if it is less than the desired count, then it will basically it will rerun the reset the replica set, and if it is the like if it is the expected one, then it will not do anything. So this is where you need to write the controller. And if you see the if you want to see the component of the controller, go to controller, and we have, okay, let's first talk about suit test. This is nothing but this will help you to once you are done with your testing, you can just do the testing in your local also before deploying in the production or in your current Kubernetes cluster. So it will just do a basic unit test. And we have AppAPI Controller. So in the AppAPI Controller, you can see that we are using package controllers, and these are the things we are importing. And then we have AppAPI Reconciler. So this reconciler is basically responsible for running this, like to resetting the state of the replica set. And if you just come little below, okay. Yeah, it's there only. So we need to have the RBAC permission enable as well. That is because we will not be just deploying this application. We will be using it to scale it also. Like we will be using the horizontal pod autoscaler to horizontally scale the application. So these are the commented out. We need to enable them. So what are the things it is using? It is using the resource app APIs, AppEQStatus, AppAPI finalizer, right? And it is also having the get, list, watch, create, update, patch, delete, right? So we need to do for deployment also. Let me just copy it from here. In the resources, it will have permission to the deployment, and then and it is having permission to the get, list, watch, create, update, patch, almost all the permission. And for our to avoid any RBAC issue, what we'll do is we'll just copy it here, and for all the resources we will give the same permission. That should not be the case in a production, but just to avoid any unnecessary error. And we want to do it for HP as well, because we want to horizontally scale our pods. Here I am using the auto scaling v2 beta 1, because this is the auto scaling version, API version that I will be using. But that is not will not be the same in your case. It depends on which auto scaling version you will be using. We did it for auto scaling as well. You have to do it for API. We have to do it for app API as well, because basically I'm just adding the RBAC permission for all the other kind in the cluster. Okay, for apps also we have deployment, also we have auto scaling, we have app API, we have. Next is this is for code API. So this resource should be similar for you. If you are doing the uh, any deployment, right, you must be having getting it, like for any kind of work also, like for deployment you have the API version apps API, so apps v1, sorry. So this is what apps v1 is. So API code v1 also we have. we need to do it for the group also that we created. So let me see the name of the group that we have. Site config. Okay, I can check it from main.go itself. It's not showing here. If just checked it few minutes back. Here. Somewhere inside API. Yeah, group version. Yeah. Yeah, so this is the name of my group. And we have to replace it here. Let me just name it. Name it like we can write a command like for horizontal scaling. This file I will also have in the Kubernetes Pedia GitHub page. You can download from there. Okay. So what we did is we created some like types for a kind of which is apps API, and then also we are giving it RBAC permission because we want to scale those app API using the horizontal scaling, and it will also have the some kind of CPU and memory requirement as well. Now the main thing is that how to get to know like what is the state. So you have to constantly monitor monitor the uh, the resource custom resource, right? What is the current state of the custom resource? You have to continuously check it. You have to watch it continuously, and based on it you can run the reconcile process just to reset the controller count. If you go below, Yeah, reconciler. So you have to write your logic here, and this will be like pretty big logic. I'll just show you. Something is one more thing. Fine. So let me just take a variable which is apps API status. Because while deploying, we will be having one service also. And next we need to uh, watch for the app API status. Okay. Service. Service. Okay, and the API version we are having v1, so v1.service. Now, how will you find like what is the status of a particular deployment, like this kind, right? What is the status of the pod count? So you first need to get it by using the labels, right? So here you are getting the labels apps API. And the name. So In the sample, I just have shown you, right? We are using one name also. You can have any sample name. I mean, which namespace you want to check. So you can give the name of the namespace. Next, you can define the spec. So this spec is basically in the sample, you can see this. Sample, but sorry, in the API, you have the sample, right? Sure. Yeah, this is where we have samples. Also, this is a spec. Like in this spec, we'll be adding the field. So that is what we are adding. Right now, what we are trying to do is we are trying to watch the container which is running. And we can give it a name. Service spec. So you know that we have spec can be anything, like whatever types we added. It could be image, CPU limit, or memory limit. So let me add image. Okay, ports also we have, right? We can add ports. Uppercase. I mean, the service port, what is a port actually? This port is AppAPI dot spec dot port. So basically, how I will be getting the port, like you are getting from here, right? So how I'm going to get which port it has. So it will first go to this port. So this port is going into apps API, which is the kind that we are using, and then the spec inside of it, it will be a spec, and inside of it, it will be a port. So these are basically the field value that you will have. So similarly, we need to write some other logic, like we have the port, we need to get to know the current replicas and what is the mean max replicas we have, and we need to check if the desired state is not fulfilled, and then we also have to write a custom logic for horizontal pod autoscaler. So we are running out of time. I can do one thing. I can update my GitHub with the latest code, or probably we can think of a session 3 to complete this part. It will take not more than 40-50 minutes. Thank you. Do you have any question?
Hey, thank you, Abhijit. That was like a very in-depth sort of like a session, so to speak. I mean, thoroughly, I'm sure
Yeah.
people would have really enjoyed it, and I'm sure it's very helpful and insightful to all of it. Yeah, I think, as you rightly said, we are just about time, about 57 minutes into the stream. So I think if you could update your GitHub repository with any of the pending things that you have on your mind, which you could not showcase today, I think I would definitely be happy to share it across to the community. Okay.
Sure. I'll do that.
Cool. So yeah, thank you again. Pleasure having you here. And any final thoughts you want to give to the community?
No, so the pending stuff is that you have to write the logics, and then you have to just build your image. So if you just check it here, the Docker file is already here. Yeah, the Docker file is already here. You need to run this Docker file. You need to build the Docker, and then you need to deploy it as a deployment. So this container will be running as a deployment, and the new application. I just talked about the Flask application or any other application. There you can have your kind like apps API, and then it will get monitored. But once you deploy this image, once you build this Docker image, then you need to deploy it as a deployment in the Kubernetes cluster itself.
Okay.
Yeah,
okay. Good. Cool. So I look forward to your link on the updated GitHub repository or something, and I can share that across or put it as a comment or something under the event title, and yeah, that would definitely be helpful. All right. So cool. Yeah, nice having you.
Sure.
Thank you everyone for tuning in, and it was a pleasure to host you, and we hope to come again with more such interesting sessions in the future. So make sure you subscribe to our YouTube channel and also follow us on our Meetup page. Okay. So with that, signing off, Ransi here, and thank you again, Abhijit.